So today we're going to talk about parent functions and transformations. And so we're going to be using the netbooks along with GeoGebra again. And so up there you're going to notice are the definitions of family of graphs and a parent graph. And so when you think about a family of graphs, okay, you should think about a family. A family of graphs is a group of graphs that display one or more similar characteristics. One or more similar characteristics. And so it's kind of like in your family, okay, generally you're going to have some characteristics of your parents. Okay, so that's what we call a family. A parent graph is the simplest of the graphs in a family. That's what the parent graph is. And so we're going to look at 4 specific parent graphs that I'm going to expect you to memorize their shape. They're not going to be tough, but I'm going to expect you to always know that a constant function is going to look like a horizontal line. And that an identity or a linear function is always going to look as a slanted line. An absolute value function is always going to look like you should already know what an absolute value looks like. What does an absolute value function always look like? A V, good. And then you're going to also be expected to know that a quadratic function always looks like a parabola that either opens up or down. And so on this next slide, what I'm going to do is I'm going to have pictures of each. Now, this is what we need to look at. So here we go. This is a constant function. If I were you, I would write in your notes constant function, and I would draw a horizontal line. This one is at y equals 1, but notice a constant function could be at any y value. It could be at 2, it could be at -2. And so just to prove that, I'm going to go ahead and draw another few lines just so that you know. I could also have one here. Okay. I could also have another one down here. Basically, a constant function, this is what you need to remember. A constant function is a horizontal line. Perfectly horizontal. Now, the equation of the given line is y equals 1. But it's going to be wherever the horizontal line is located. So the pink one would be y equals -1. What's the green one going to be? Y equals -2. A little bit about the constant function. The domain is all reals. Okay, because the line goes on forever to the left and the right. And the range of the blue line is 1. What would the range of the pink line be? -1, good. And the range of the green line is -2. So the range is going to be wherever the line is. So that is the constant function. Next we have the identity function. This is also called a linear function, so make sure you get that down. A linear function. Root word of linear is line. So a linear function is any line. Now notice this needs to be a slanted line. So the first one is y equals x. Domain is all reals, range is all reals. Will always be the case with a linear function. Once again, you could have some really kind of funky lines. You could have something like this. You could have something like this.
So it's always all reals, all
Yes.
reals for domain range.
Perfect. Always all reals, all reals. So what you're memorizing here is you're not memorizing that actual line, you're memorizing the shape. The absolute value function is a V. We've looked at numerous absolute value functions in the last 2 days with GeoGebra. And so we've went through the domain and the range, so that shouldn't be any trouble. You should be fine with that. And last but not least, we have the quadratic function. The quadratic function is a parabola. Parabola that either opens up or down. So a parabola could also open way, like that. Real similar to the absolute value in terms of how you find the domain and the range. So I think you should be able to remember those. So those are the four I need you to memorize. I need you to memorize their shape. A constant function is a horizontal line. A linear or identity function is a line. Absolute value function is a V. And a quadratic function is either a smile or a frown. Okay. So that's what you need to remember for me. So now we're going to test your short-term memory skills. And I'm going to give you an example, and you're going to have to tell me which of the four is the graph. Okay? So, first one. Identify the type of function. Is this one A, B, C, or D? Quick, 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 quick. I don't want you looking at your notes. I want you to go off of your memory. Quick, quick, quick. What is it going to be? You might need to turn them on. All right, so perfect. Nice job. C, that's an absolute value. We should have all gotten that one right because we've been studying those quite a bit. What's this one? Quick, quick, quick. Nice, constant. Good job. Here we go. Next one. What's that one going to be? There you go. Good job. B is your answer. Okay, and the last one. What do we got for the last one? Nice. Good job. So that's what you're going to have to do come test time. You're going to have to identify what those are. And right now we're only starting with 4. Eventually, we're going to make that, instead of being 4, about 8 to 12.
Jeez.
Okay, but that's what we need to remember for right now. So now a transformation, now I don't know if you necessarily need to write this down. Okay, this is something that we're going to cover in a little different than the way the book does. We're going to alter a parent graph by translating the graph, rotating the graph, or dilating the graph. So first of all, let's talk about what a translation is. Once again, don't know if you need to write this down, just be aware. A translation is moving a figure up, down, left, or right. So basically this is called a slide, a shift, or a glide. Slide, shift, or a glide is what we're going to be talking about now. So in GeoGebra, I want you to graph the following. Y equals the absolute value of x plus 2. So I want you to quickly just graph that. Shouldn't take very long. Remember how you're going to enter that in. You're going to do y equals abs, parentheses x, parentheses plus 2. Go ahead and graph that. Now, what I want you to do is I want you to remember that very first absolute value graph that we had on the slide about 5 slides ago. I want you to think of how that looked.
Mine's not being launched though.
Okay, and so I want you to think about how that very first graph looked. And then what I want you to do is I want you to go ahead and tell me what is different versus this graph and versus that other graph. So what's different from this graph and the other graph? The first graph was in blue, the second graph is in green. So what have I done to that second graph? Moved it up? How many? 2. I've moved it up 2, so I have translated the graph or slid the graph up 2. Where do you think the 2 comes from? Ah, the plus 2. Good. So let's just think, what happens if I would have had the absolute value of x minus 3? What would the graph have done? Went down 3. Good.
What's the difference between a slide and a glide?
Nothing. Some people just thought it's a light it up to. It's just a different word as to, if you didn't catch that question, the question was why do you call, why would you call it a glide? Some people call it different things. I always call it a shift. Okay, but That's what some people call it. So let's describe the translation here. So let's think about that real quick before you type it in. I want you to think about, what is this graph going to do? What do you think from just looking at it?
-4.
Yeah, so what's it going to do?
Go down 4.
Go down 4. Good. Graph it and see if that's what you get.
Oh, crap. Really good mind.
Okay, now how you do the x squared, if those of you are wondering how you type in x squared, you're going to do y equals x. You're going to find the caret key on your keyboard. The caret key is the one that looks like a hat. Okay, we call it the caret. No, you don't do ABS on this one. You're going to enter it in exactly as I have it in blue. Where's the caret key? 6. It's shared with the 6. Okay? So y equals x is caret 2 minus 4.
Oh, do we have to delete the other one first?
You can delete the other one if you don't want that. And so if you notice, if you got it to graph correctly, your graph should have been slid down or shifted down 4. Okay?
Curves.
Like, what do you mean you see that?
Maybe I don't have that one in there. I thought I had it in there. What?
Were we supposed to put both of them in?
No. Okay, so our original graph, I thought I had this one in here. Our original graph, this is a quadratic, is going to look like this.
So all these are going to
Oops.
start at 0.
That's going to start at 0, 0. Right. And then this one's going to be shifted down 4. So the one you graphed should be here in green. Should look like that. Okay? I thought I had the graph in there. Must not have. Okay, so now we're going to talk about a reflection. When you think of reflection, I want you to think of a mirror. What does a reflection do? Flips it, right? So that's why we call it a flip. So if I think about this negative x squared, before you even graph this, we know that x squared looks like this, right? What do you think that negative x squared is going to do? Make it a what? A frown. Why don't you see if that works? So go ahead and type this in and see, because right now it's a smile. Let's see what that negative does.
Yep.
So is your conjecture correct?
It stays at 0 though.
It stayed at 0, right? And so basically all it did is your line of reflection is that x-axis, and it flipped it over that line. So we can imagine that a mirror is here on the x-axis.
So when it says describe the reflection, would you just like...
It flipped it, yeah? So let's look at this one, a dilation. A dilation, when I think about a dilation, I think about either shrinking or enlarging something. So you're either making it bigger or you're making it skinnier. Okay? So like a lot of kids, when they go to college their first year, they dilate. They dilate, yeah, bigger. Okay? Because that's generally what happens. And so let's go ahead and describe the dilation in y equals 4x. Now we know that y equals x is just an identity line. What do you think the 4x is going to make it do? Yeah, make it 4 times bigger. So graph y equals 4x and see what happens.
What happened?
So what did it do?
It made a
Just did it.
slanted line.
It made a slanted line. Now when I think about y equals x, I think about the 45-degree angle it is. Actually this way. Okay? What did the 4x make it do? It slants up more. So it basically grows faster. And so, in looking here at the graph, there's your y equals x line. Notice everything's kind of nice. The 4x makes it steeper. Now, what do you think would have happened if this would have been like y equals, let's just throw something out there. Y equals 1/4 x. What do you think that would have done?
It still would have raised it a little bit.
I want you to try that. I want you to type in 0.25x.
Like this.
0.25x. Whoa, what did the 0.25 do? Made it go this way.
Dang.
Okay, so the bigger the number is, the faster it's going to grow. The 4x is growing really, really fast, getting high really quick. The 1/4 x is going to take a little longer. So anyway, that's a dilation. Okay, so let's look at this one. I want you to go ahead and do that one, y equals 2x squared. So remember what I said, by multiplying by that number, it made it go bigger faster. So what do you think is going to happen to that parabola? Is it going to go fat, or is it going to get skinny?
Get that.
Let's see, is it going to go fat or get skinny?
Skinny.
Skinny, because it's getting bigger faster. So your normal one is gonna look like this. The y equals 2x squared is gonna do this. Okay, so that's what your y equals 2x squared is gonna look like. Okay, so questions? Pretty cool, huh? All right, so this is what you're gonna do. All you're gonna do on page 10 through 31, I need to walk through the assignment with you, and then I'll go ahead and let you go with your GeoGebra. On numbers 10 through 31, first of all, 10 through 13, that's just like the expression questions we did. Identify what they are. On 14 through 31, okay, this is what you're going to do. You might want to have graph paper if you like to draw and graph. Otherwise, you can do this on your notebook paper. You need to graph those using GeoGebra. And so basically on number 14, if I look at 14, what is that graph going to do from the normal y equals x squared?
Add 4.
Yeah, it's going to go up 4. So this is all you're going to write. Up 4, draw the graph. For number 15, what are you going to do? Down 3. So you can write down 3, put an arrow, the down arrow in 3, and then draw the graph. That's all you're going to do.
Well, if you
Okay.
so you have to draw the graph, but with like a red one and a blue one, like the two different ones.
You don't need to do the
Or
two
just
different
the
ones.
new one?
Just the new graph would work.
So we can do it on GeoGebra. And
Yep, yep.
Draw it.
Do it on GeoGebra, look at the image there, and then draw that same image on your paper.
What is he gonna be doing now?
Maybe by the end of the period, if I give you some time to work.
I have a question.
Yep, just a second.